In this module, we'll cover a couple basic strategies for dealing with missing data, and then we'll cover a modification of the decision tree algorithm. We're actually going to be able to deal with missing data in a much smarter way. Now, the basic, most common way of dealing with missing data is what's called purification. So I'm just going to throw out missing data. So I start with a data set where for some data points, some of the feature values are missing, and somehow I'm going to skip some of these features, some of these data points, and end up with a data set in outputs here, h of x, where nothing is missing, everything is observed. So skipping data and purification through skipping data is the most obvious thing that you might want to do. So if I have 9 data points over here, and 3 of them have missing data, so these are the 3 rows here, then I could just say, okay, there's not only 3 missing, not too bad. I'm just going to skip them, and so I'm going to take my 9 and decrease it to just 6 and call that my data set. And if you only have a few missing values, maybe this is an okay thing to do. Skipping data points with missing values, however, can be a problematic idea. So for example, in this case, you have the feature term missing in a lot of different data points. In fact, 6 out of 9 data points, the term feature is missing. So if I were just to skip those, I would go from a data set with 9 features, so with 9 data points, to a data set with only 3 data points. So it would become much, much smaller. And that's really bad because term here is missing more than 50% of the data. So if you look, we're going to go down from 9 to a much, much smaller value. And that can happen and makes your training much worse because you have much less data at the end. And so in these cases, if you just have one feature which has lots of missing values, another simple approach is to say, instead of skipping data points, you could skip features. And now, instead of having fewer data points, you just have fewer features. So that's a reasonable alternative in this case. So there are 2 basic kinds of skipping that you might want to do when you have missing data. You can either skip data points that have missing data, or skip features that have missing data. And somehow you have to make the decision of whether to skip a data point, skip features, or skip some data points and some features, and that's a kind of complicated decision to make. In general, this idea of skipping is good because it's easy. It kind of just takes your data set and simplifies it a bunch. It can be applied to any algorithm because you just simplify the data and you just feed it to any algorithm, but it has some challenges. Now, removing data, removing features is always a kind of a painful thing. Data is important. You don't want to do that. And it's often unclear whether you should remove features, should remove data points, or impact will have on your answer. What do you do? And most fundamentally, even if you didn't skip too much at training time, at prediction time, if you had a question mark, what do you do? This approach does not address missing data at prediction time. And so people do this approach all the time, and I'm okay with it if you just have kind of one case here or case there, but it's a pretty dangerous approach to take. I don't fully recommend skipping as an approach to dealing with missing data.